Good morning, everyone. My name is Sonia Sakovich. I'm with Sprint. I'm the peering coordinator. The panel we're going to do next is the SIP peering panel, discussing operational experiences from various perspectives. I have to tell you, I came down here this morning, and, I was here a little bit early, and I was walking around in the hallway outside, and I noticed all these people in suits walking down toward the other end of the way there, and I thought I, was in the Seinfeld bizarro world of Nanog, because all these people who were in suits and everything just wouldn't be this group that was here. So they're actually part of a different conference, so I felt a lot more comfortable when I saw people in normal attire start walking around. So anyway, so I've been the peering coordinator with Sprint for about a year and 4 months, and back in the fall, I had a request come to me for peering, for voice peering, which I really wasn't familiar with. And, as everyone tells me, the Sprint standard response is always when someone asks you for peering. Anybody know what that is? Well, it's usually no the first time around. That's what they tell me anyway. So I brought the request over to my associate Yi, who is involved in SIP and voice peering for Sprint. And he filled me in a little bit on the background and what it's all about and some of the issues that are going on. And so we thought it might be a good idea for a Nanog panel. So today we're going to hear 4 different stories from different perspectives in the SIP voice peering world. Let me introduce our panel. We have Josh Sahala from Intelepeer. He's going to talk about Tales from the Dark Side. I have their bios up here as we're going through as well. We have Tim Cody from Neustar. He's going to be discussing using ENUM to solve SIP routing problems. And you can see in his bio that he was a rocket scientist, and yes, he really was a rocket scientist. We have Matt Christopher from Comcast, who's going to be discussing SIP and BGP. And finally, Yi Chu, my colleague at Sprint, he's going to be discussing data meets voice. So, in preparing for this panel, I was reviewing a Network World article in a December issue, which discussed some of the predictions for 2009 for voice and IP, as well as some of the results. And I wanted to share a couple of those predictions and results that either came true or didn't. And one was that 4G apps were supposed to be really big, but apparently they weren't very big in 2009. Another one was that infrastructure suppliers were going to focus less on innovation and more on execution, with an emphasis being on the user experience, and that really did happen. And as these panelists talk, we'll see if some of their stories, how they match up with some of these predictions or not. And after that, we're going to list a couple of the 2010 predictions that were in the Network World article. It was actually called a Converge and Voice Alert. Convergence and Voice VoIP Alert, that's what the article was. And we're going to ask some questions and open it up for discussion. So with that, we'll bring up our first panelist, Josh Sahala. You're the next one. Keep going. In the same one? Keep going. That's the Intelepeer. What's the rest of it? No, that's right.
Whoops. I shouldn't have posted that.
It's a Windows.
Tuesday.
Oh, there you are. Sorry. Yeah, we got it.
Yeah, is that on the desktop? restarted that. Okay, here we go.
Silly Windows boxes. My name is Joshua with Intelepeer. We're an enhanced voice application service provider. Our core business is wholesale, carrier-to-carrier type things. So, pardon me. So, a brief history. SIP is a application. You can read this slide. Sorry. Thank you. So within SIP, you've got various network elements, the URI, Uniform Resource Indicator, Universal Resource Indicator, user agent, So, here to talk about what keeps us up at night. Things that, as a SIP operator, I have to deal with on a daily basis. So, there's SIP standards and various interpretations of those standards. Like a lot of protocols, proprietary things are good for the vendor who wrote it. For me, it leads to lots of interesting issues between different vendors. It's a lot harder to do multiple vendors than it probably should be. For example, the way that Sonis, you can customize the DTMF type and the codec for individual service profiles on the Sonis. You can't do that on other vendors. So you agree to details when you're turning up and when you're testing and retesting, and the interop is really quite time consuming, and it often still doesn't work. The testing trunk group will be configured different than the production trunk group. And a lot of it leads to having to sit there and look at the traffic and decide, oh, gee, they changed something. Or we changed something, and now it doesn't work. And going between codecs is really quite resource intensive. G.711, lots of short calls, makes it really hard on the switch. So how do we keep it all running? Write some tools, buy some tools, rewrite, buy some other tools. As it says, on my network, it's kind of a hodgepodge. We've got different things looking at different pieces, and sometimes they work together, sometimes they don't. I unfortunately don't have an example of the CDR, but it's, I don't know, I think 60 fields and a comma separated value. Pretty ugly. Upgrading between various, upgrading from one patch release to another or one major release will sometimes change the value of some of the fields. So rewriting. And then figuring out, so this IP event caused this voice event, or did this voice event, like the correlation between is quite difficult sometimes. Certain tools will focus well on, certain parts of it, but they have no visibility, or there's no way of getting visibility into another part of it with that tool. And then you have different people looking at the tools. So, the voice people understand the voice stuff, and the IP people understand, the infrastructure, and trying to figure out who's responsible and who to talk to and how to talk to them has been an interesting challenge. Because sure, it's an IP application, but someone who understands what each of those 60 different fields in the CDR means, to me it isn't as interesting, but one of the odd things when I started was chasing down some intermittent packet loss. It was a very, very small percentage, and in the past it wouldn't have mattered. But the way our network vendor, our network hardware allocated the queues didn't work quite the way that the traffic mix needed. So running around in circles, trying to figure out, what's the problem? Is this really a problem? So have to work very closely with the vendors. Each time we go through an upgrade, make sure that the log formats are the same. Several ongoing projects to try and improve the correlation between the voice events and the IP events, and standardizing the communication, making it a language, or figuring out the language that each group can understand. Writing things down, rewriting them, educating, testing, more testing. We're a small company, but we've seen a lot of growth in the past couple of years. So one of the big projects has been to move out of our small, multiple cabinet type space into some larger dedicated cages. And, there we go. Sorry, skipped a slide. So I'm sure a lot of you have been through migrations. Unfortunately, it isn't quite as easy as just, flipping one switch off and the next one on. We tried build and kill, but it's expensive and time consuming. So the last one and the next few are going to be a little bit of build and kill and a little bit of just, it's kind of coordinated mayhem. So, as a small provider, going and talking to larger providers and saying, "Hey, do you want to peer? Do you want to exchange this?" It's a really different paradigm. the old PSTN voice paradigm is most of my coworkers come from that background, and the SIP application IP doesn't really make sense in terms of why should we peer versus let's just turn up another circuit. And some of the larger people that we work with, they want to be paid for the circuit and the minutes. So it gets to be kind of an expensive proposition. So one of the things I've been working on is trying to educate both people within my company and the people that they talk to figure out, does peering as, the ISP thinks of it make sense or not? Questions, comments, flames?
You can probably hold the questions till you. Okay, thanks.
Magic here.
I do have one comment. Anton Capella from Five Nines Data. SIP peering seems to look a lot like an IXC with a lot more interop problems. I'm naive, and I want to know why SIP is more interesting than standard ISUP, MTP, whatever that we already have. I just want to know where does SIP come into the game for what already is kind of an IXC operation.
But I think SIP is basically an SS7 signaling replacement, and using SIP on top of an IP network allows you to use a converged network. You don't have a dedicated TDM-based, SS7-based network that's running in parallel to the rest of your IP network. Instead, you can throw voice on top of an IP network and basically operating as an application. SIP is new, especially for inter-carrier signaling, right? And I think we're kind of maturing through that process right now. Vendors are maturing through that process, and ultimately, SIP interop I think is a little easier than it is today, but we have to cut our teeth.
Okay. Well, thank you for your comment.
Okay. So my name is Tim Cody. I'm from Neustar. We're going to talk about ENUM and more specifically, I guess, number portability and how you route services over IP. So the first thing is really how does this concept called Carrier ENUM work? There's different flavors of ENUM. There's a concept called public ENUM, which really hasn't gone anywhere. What we're seeing that is really starting to take off is a concept called Carrier ENUM. This is where effectively the carrier that owns a telephone number around the world will populate the data into a registry, very much like DNS, to effectively associate telephone numbers with services over IP. So to make this work, you need a kind of a tier 0 registry. And right now there's a couple of them out there, but the one that's most, I guess, prevalent is being used is from the GSMA, which is the kind of the trade organization for the GSM carriers. It represents, I think, a couple of billion telephone numbers around the world today. So that's kind of where the tier 0 registry lies today. Then you've got a concept called tier 1, and this is where could be different countries, regulatory bodies get involved, and state. And this is going to be the tier 1 registry for our country. In the United States, we've got a couple of registries that are still, we're trying to figure out which one's going to do what. One is called CC1 ENUM, and another is called the NPAC, the Number Portability Database, which actually is used to route telephone calls, voice calls today with portability. And then lastly, you've got the tier 2 registry. And this is where your actual route information could be. And one of the issues you've got to worry about is based upon, and this is a complete discussion not for here, but what we've seen with peering is it's not necessarily a technical problem. I think technically, as Josh mentioned, there's interop problems, there's those kind of things, but What we've really seen where the issue is on the business side. Voice has a 100-year legacy for good or bad, and there's a lot of issues with inter-carrier compensation, that kind of thing. So carriers may or may not want to expose routes to other carriers. They may say, you know, I don't want to receive instant messaging traffic from this carrier or this service provider. So what the Tier 2 registries do is they apply policy and let you decide who you're going to make your routes available to. And as I mentioned before, number portability is a big deal, because one of the things behind ENUM, and the RFC, in case anybody doesn't know, is RFC 3761 is kind of the overarching RFC. But one of the things people with ENUM is based on telephone numbers. And you're going to get back to these multiple IP addresses with service routes attached to them. There's billions of telephone numbers today. Amazingly, we actually have a standard for this, E.164, that everybody in the world agrees to. So instead of trying to reinvent the wheel and come up with some different standard for username, ENUM kind of uses the assumption that the telephone number would be that username. So today, number portability has been implemented in 55 countries. Every solution is different, and they generally sometimes are complex and costly to deliver traffic. So this is kind of an example of this global inconsistencies. So you've kind of got a number record holder, a number holder. And so if I've got a call where I'm going to originate, and I don't really care how I originate the call, whether it's TDM, IP, whatever. I'm going to go through an international carrier hub to get it to the other side. Well, the recipient, as you can see, is actually down at the bottom. But I'm going to have to go through the number range holder to get to the recipient. So just to use an example in the United States, if I wanted to send a call, the number holder, original number holder was AT&T. But I want to get that call to Verizon. That's who actually the number has been ported from AT&T to Verizon. Well, if I don't use a number portability database, I'm going to send that call to AT&T, and then AT&T is going to have to forward it on to Verizon. And what's going to happen is AT&T is going to charge, and Verizon is going to charge. So it'd be more effective if you knew up front where the destination was. That if you knew the destination was Verizon, you could just send it directly to them. And so that's why these number portability databases are important, even in an IP world. Because it gets really tricky in an IP world where I could have multiple services attached to a single telephone number, and these services could spread across multiple service providers or carriers. So I could have instant messaging with Google, I could have voice with Verizon, I could have video with Comcast, I could have, I could have my presence information from another carrier. And so how am I going to get that to another user, especially with my numbers porting around? So this is a kind of example. I'll kind of talk through this with routing challenges. So if I'm the originating carrier, depending on where I'm sending the call to or the communication session, I may use a different hub to get there based upon my business relationships. So in this example, if I'm sending it to carriers A or B, I need to send it through a certain hub. And so if I don't know that the number has been ported to a different carrier, I may send it through the wrong hub provider. Call may not get there, or the session may not get there, or it may get there, but it's pretty expensive. So transition phase. With number portability, obviously that's very important to get this data in one spot. And today it's typically accessed using SS7 or C7 overseas. And there's, like I said, there's 55 countries around the world. So you definitely don't want to go and do business with 55 different countries and all their interesting rules about how you get access to that data. So what GSMA is trying to do is aggregate this data into one spot. So whether it's number portability data for France or England or Spain or Portugal or the United States or Brazil or wherever it is, put that in one spot. And then as IP routes get populated in these registries for whatever service you may envision, SMS, MMS, voice, video, IM, whatever, you put these in a single spot. So you do a single dip. So you can do one query using enum, and you can get back multiple routes. And then you can decide how you want to route to that destination or that service. So some operational issues we've seen. One thing we've seen is a lack of and I hate to, this is a very TDM term, a lack of a class 4 IP network. Carriers do not, there's a constantly N squared problem. Carriers do not want to do bilateral agreements with every other carrier on earth. They would prefer to have a certain number of bilateral agreements based upon strategic and business needs, but they would ultimately like to be able to route traffic to one or several class 4 networks and let them take care of getting the traffic to where it needs to go. So that's one of the things we've seen. Number portability, which I've really talked about. Usage of existing voice routing databases. So today for text messaging or MMS, where you download content or you send a picture to somebody, today those applications use the voice routing databases. So in the United States, they use a thing called the LERG, and they use a thing called the NPAC, Number Portability Database, to find out who owns this telephone number, and that's how they route. The problem with that is these databases were designed for routing information called an LRN. And LRN has nothing to do with voice or SMS or MMS. So they route off a thing called a SPID. It's basically a carrier ID. It says, I want to route this to AT&T. This is AT&T's carrier ID. That's how I'm going to route it. The problem is carrier ID is not always accurate for many reasons. Carriers may acquire another carrier. They may do certain things. So there's a variety of different things. And then lastly, you need a single authoritative registry, kind of like ICANN, to be able to put this information in one spot. And just a couple of quick ones. With registries, you have the ability to control your inbound traffic. So you can go and change IP addresses. So carrier queries your telephone number today. They route in through one IP address. You go change that in the registry. All your peering partners will automatically get that data, and then they would route to your new IP address. Different routes for different service providers. So I may want to say, for my voice routes, I want to peer with AT&T or Verizon or Sprint. With my IM routes, I don't want to peer with Google for voice, but I do want to peer with them for IM. So they can get different routes based upon who's making the query. SMS to wireline carriers, this is a big deal. Wireline carriers want to be able to offer texting services, but like I said, they use these public databases today. And by definition, wireless service providers will not send a SMS to a wireline provider. So you need a way to override that data, and that's where these registries come into place as well. This is just SMS. You can see this, how it works. SMS operates and MMS as next hop routing. There is no direct peering between, let's say, AT&T and Verizon today, and it probably will not be any direct peering for those services with them. And then just summary, ENUM is a technology to access this data, whether it's number portability data or services over IP routing information. And that's all I had.
Does anybody have any questions right now, or do you want to wait to the end?
Thanks, Tim. Control L. Sweet. Hi, my name is Matt Christopher. I'm with Comcast Cable, our National Engineering Technical Operations Organization. For about the last 3 years, I've been really focused on SIP interconnects and exchanging voice traffic using SIP. So Comcast has built out our infrastructure, SIP, and using ENUM protocol for phone call routing. We built that out internally, used it for on-net traffic, and now are pushing it to inter-carrier voice traffic exchange. So, touch on 4 points today: the value behind voice pairing, why it's beneficial. Look at Comcast peering architecture. We'll go through an example that shows kind of the inner working between SIP and BGP. And then a quick slide on some tools that Comcast is using. So value behind voice pairing, is somewhat self-evident, I guess, but that you're really exchanging traffic with another carrier. There are a lot of, Tim mentioned some of the inter-carrier compensation regime that exists, and a lot of those rules and terms and rates and negotiations and agreements are not necessarily applicable in this day and age, and honestly a lot more complicated than it needs to be. So by exchanging traffic with a trusted peer, when you have a balanced traffic to exchange, then it's beneficial to have a direct relationship, and ultimately you're removing expense from your business. So using SIP and BGP enables that to happen. So here's some more background on why this is meant to kind of show how complicated it is. But we have all these legacy rate elements: common transport, common MUX, tandem switching, tandem transit, common carrier line. From the inter-carrier compensation regime, these terms had value, but in today's day and age, the technology is different. Really, the access networks are different. Things just they don't mean the same anymore. In this particular example, you see a phone call from carrier A to carrier B, another phone call from carrier B to carrier A from a rating, billing, compensation perspective, the two carriers just end up charging each other the same amount. And at the end of the day, besides wasting a lot of energy on rating and defining the calls and understanding who the calls came from and who to bill and potentially even who to dispute a bill with, right? You end up, wasting all that energy, and your net revenue associated to the whole process is zero. There's also tandem providers involved in the situation, and as transit providers, they definitely provide value. But if you have the right sweet spot with a peer where you have a lot of traffic, then it makes sense to go to them. So how do you know who to peer with? Tim mentioned number portability, and at least in North America, it's very important to account for number portability corrections. So you want to look at where your minutes are going, and these are area codes, MPNXX exchanges, corrected for number portability, and track your minutes by destination. So in Comcast's case, this shows the chart here on the right is our distribution of our top 98% minutes. So you can see that 63, and this is domestic, so in the United States, 98% of our minutes are destined for only 63 different voice providers in the United States. So you can find, from a peering perspective, you find what your sweet spot is, how many minutes you're sending to those peers, and that's who you want to start approaching. In some cases, the technology may not be in place for the prospective peer, so you're challenged from that perspective. You may have disagreements on the agreement. You don't share the same vision, but you have to talk through those issues with the prospective peers, and then approach them with a technical solution. So in Comcast's case, I think 75 to 90% of our minutes is rural. We're approaching it, and the rest of that long tail distribution, we're more than happy to work with transit providers to get those minutes where they need to go. So how does Comcast do it? We have, Comcast is a cable company, so we have a packet cable-based voice network as access to our customer, but SIP peering can work with any type of provider, wireline, wireless, cable, etc. So our network on the left there is specific to an MSO environment. Where we've added the voice routing intelligence is really in the middle. This facility we have called it as an APOP, is an application point of presence. It's a POP for all of our application servers. So we have an intelligent routing database there with a SIP route proxy and our session border controller. So a session border controller is kind of like a voice firewall, provides topology hiding features so that we don't have to advertise out all of our customer IP address space. We only have to advertise out the SBC IP address space. So it helps protect us from those attacks. We aggregate signaling and media through the session border controller, so it provides the protection function from there. The SIP route proxy is it's kind of like a SIP load balancer a little bit, that we're really taking invites from all of our CMSs, our call management servers, kind of equivalent of a class 5 switch in a legacy voice network. And the CMS is making an initial routing decision, usually a local routing decision. So it's only looking at the MPNXXs within a specific geographic area. If it determines that this would be a call outside of its geographic area, then the CMS sends the SIP invite to the SIP route proxy. SIP route proxy does an enum dip into our intelligent routing database where we're defining which phone numbers point to really which destinations in terms of a peer's session border controller. So once that egress path is defined, then it's, at that point in time, the request URI is going to say this is your next hop, which is going to be the Comcast SBC, and, also what from the Comcast SBC, which peer's SBC you want to send the particular invite to. So at that point in time, the two endpoints are somewhat deterministic. You know it's going to hit this SBC on our side and a peer's SBC on the other side. So things to keep an eye on with the inner working between BGP. I think a lot of times you'll see, teams say, well, we're the network layer guys. We don't need to talk to the application layer guys. And sometimes the application layer guys have the same mentality. So it should just work. But what we found is that you really want to understand physically where you put your session border controllers in your network. all of our SBCs are located in our APOPs, but our major APOPs are within, 3 or 4 router hops from all of our backbone peering points. So that, we couple our peering circuits, the physical interconnections with the peer, with the same SBCs in the same cities. So we make sure we take advantage of that deterministic path. An invite coming out of the Chicago SBC, for example, we want to go across a Chicago peering link, not a New York peering link or a Los Angeles peering link, and that's for the vast majority of the time. So you avoid a lot of hairpinning all across the nation just to get these voice and media packets between each other. So it's important that the two teams, your voice team and your network team, are working together on making those decisions, and that they understand the impacts to each other. So here's an example of some link outages that we had. This is with one carrier and a set of 4 links that we had in one of our peering sites. So the graph on the left shows transmit and receive packets. With this particular peer, we have 4 GigE links. So you see 4 outages occur. The first one is just 10 before 10 in the morning. The second outage is 10 minutes after 10. The third event is at 10:40, and that's where you see all of the yellow there, that 3 of the 4 links have been removed from routing. And then the fourth event is around noon. So the traffic from a BGP perspective, this is solely looking at the GigE link, not necessarily at the voice application layer, but solely looking at the links. You see that the traffic shifted from 2 other sites and actually shifted in an asymmetric manner. The transmit packet shifted to one city and the receive packet shifted to another city, but it was for only 2 of the 4 events. So the other, or it's only noticeable, for 2 of the 4 events. But with BGP reconvergence, a typical conversation, right? You're sitting there, if packets are not being received at the other end, that equates to dead air, dead air time on that phone call. So BGP is reconverging quickly enough that customers aren't experiencing a dead air situation, or that they're desensitized enough that they'll wait a couple seconds, right, before the other end will hang up. So that becomes a customer experience, is really a hang-up situation. And as Josh was mentioning, it's hard to, there's really no way to detect that automatically. A hang-up is a normal end of a voice conversation, right? So you don't know what normal hang-ups are occurring versus which customer hang-ups are occurring due to some type of an outage. So correlating between the two can definitely be a challenge. So what I did is overlaid this peering site GigE link volume, and it's a little hard to pick up, but the graph behind it are the concurrent session counts on the session border controller. So you can see that the GigE link outage events didn't have an impact on how much traffic was being carried on the session border controller. We were still keeping calls active throughout this outage event. So BGP is basically doing what it's supposed to without creating an impact at the application layer. There was the second event at 10:10 is the one instance where we see that some of the customers would have experienced dead air and hung up their phone, and we see a sharp volume a decrease of calls on the session border controller. So there are a few things that are helping us. BGP, we have BGP hello timer, SIP options ping is doing essentially the same thing at the SIP level. Well, these are 3 or more minutes, right? So none of these are going to help us from a customer experience perspective. The customer is not going to wait 3 minutes, right, before they hang up the phone. So it really falls back to BGP convergence. If BGP convergence time is quick enough, then customer experience is effectively, it's transparent to them, I guess. How else we're protected at the application layer is not so much for active calls, but for new calls that get established. So the SIP invite timer is almost a 4-second timer. You're sending out 3 SIP invites. If the first invite doesn't reach a peer, second invite doesn't reach a peer, third invite doesn't reach a peer, then the intelligence you want to build in your network is to try a different path, or even more so, potentially even a different carrier. So you use a peer as your first preferred path. You can't reach that peer, then you route advance basically to a transit provider. So you have you're going to increase the availability of your network. You may add in, a little bit of expense, but you're doing that, to improve your customer experience. Some tools that help in Comcast, a lot of them, are really just based on SNMP polling. So we're bringing in SNMP data, and in this example, the session border controller is, from those SIP invites. If 3 SIP invites are sent, no response is received from your peer, then the SBC generates a SIP 500 message, a server failure, which is equivalent to like an ISIP 34 or a route advance message in a voice TDM world. So we can track these SIP 500 messages, SIP 503, for example, and trend them at the same time and day of the previous week and look for spikes. So we'll look then for spikes compared to the previous week, trigger an alarm or at least a notification for our operations team to look into it. At this point in time, it's not customer service impacting because we have chosen to route advance to a transit carrier in the event of, like a layer 3 outage. But this helps us make sure that the customer experience will continue to stay positive, in addition to helping us control our expense, because the transit provider is not necessarily our lowest cost route. So in closing, we kind of touched on, the why. Why does peering make sense? SIP voice peering makes sense. You get to establish a direct relationship. You have, a lot more leverage in that type of situation. Working together with a carrier, you want to focus on, your top opportunities. Helps reduce voice operating expense. How you do it, you need to account for number portability correction, at least in North America, making sure you're looking at who owns the telephone numbers, not necessarily just what the MPNXX is. Make sure that your BGP and SIP teams are working together, and make sure that you have carrier and site diversity. Without those two things, then SIP network, SIP on top of BGP doesn't work as well as it should. To sustain, use SNMP polling, and start building tools to help correlate performance data at the application layer and at the IP layer. So a couple contacts myself. Jeff Barr is within our product engineering team in Comcast, and then Jason is on our BGP side, who helps us set up all the interconnection. So, thanks.
Can you make your slides available before the end of the day? Is that possible?
Yeah, I think so. Well, it depends on how you're going to use them.
Hi, this is Sprint. I'm going to get you down to the weeds now in my presentation, get down to the bits and bytes. Just kind of give you a kind of interesting story about the conflict or coincidence of a byte choice, byte pattern choice, which has some interesting impact to how we capacity engineer our IP path. So what happened was there was some sort of congestion event, and this is the diagram. It actually, Tim and Josh talked about the voice guys and IP guys. They don't always actually the importance of voice guys and IP guys talking to each other. During this event, it's pretty hard for the voice guys are getting a lot of tickets, complaints from customer, and they couldn't figure out why. And it took them a couple of days to nail down the IP. Nail the IP guy says, okay, that's your problem. So obvious from this chart, you see the traffic is clipping, and so we also notice that there's asymmetric traffic. The ingress is clipping, the egress is not. So, it happened that we have multiple paths, and the paths are not really balanced well. So problem solved just by dealing, a better load balancing the two directions of the traffic. But what's strange to me is that the clipping seems to be a little bit earlier than, usually you would expect. It's like around 85%, right? Usually in IP pipe, you see, okay, yeah, clipping at the 95%, it's normal, but 85 is way too early. So a little bit background. On this pipe, it's an OC48 pipe, and mostly I know on this router, 90% of traffic is VoIP traffic, so it's always symmetric. And on the voice application, we all know it's G.711 encoding, no silent suppression. 20 millisecond packetization. This actually helps me to calculate the packet per second. So at first, we were kind of suspect it's the route card, the packet processing is the culprit, right? But in the end, we did a calculation. The packet per second is not a problem, and so what? So I asked Ron, and Peter actually mentioned something about the HDLC framing. It might have something to do with that. So I looked into the HDLC framing and what it is. What I found is that there's an interesting thing about the flag. So HDLC, it's variable framing size encapsulation. So the flag is 7E, and so in the data portion of that frame, you have to escape that. So 7E, 1 byte of 7E, you basically need 2 bytes to transport it on the wire. It becomes a 7D and a 5E, and then you need to escape 7D. 7D becomes 7D and a 5D. So that is the HDLC framing standard. Then next I looked at, actually I had to, we don't have live, data, sniffing data from network. So I had to call up a lab, and they did the lab capture of this 711 ethereal capture. What I noticed is, if you notice, there is a lot of 7E, So a lot of 7D and 7E. So why? The question is why, right? Because if these bytes are in the HDLC frame, then you need 2 bytes to transport 1 byte, and that's going to cause a problem. So again, I asked around, and my college professor, Dave Peter from University of Kansas, actually, he was one of the patent holders of ADPCM, so he knows a lot about the voice encodings. So from his perspective, it's just a regular voice encoding. It indicates a low voice energy, meaning you're not talking. So I also looked at the G.711 spec, and so there is, the specs, 7E, 7D, these are basically silence, period. So what turns out is that it's pretty interesting. When you're not talking on the wire, we're using double the bits to transport on the POS links. So I guess some of the older, data guys and like Peter or whatever, they probably knew about it. But, new guys like me, it really was a surprise. And further on, I also did some calculation based on the ethereal capture. Basically, during the silence period, we are using about 27% more bits down the wire just to transport your silence packet when you're not talking. So the implication is when you do the capacity planning on your POS links, you really need to leave some extra headrooms because of this effect. I think, if you look at enterprise, probably the codecs are not 711, but on all the carrier side, we do use 711. And I also looked at, when these standards were made, right? 711 was in the 80s and HDLC in the 1990s. So kind of soapboxes, so when the HDLC guys, when they make the selection of this framing by, they could choose a different by pattern, then we wouldn't have that problem. But anyway, so here's just the kind of an interesting artifact, and it came to me as a surprise, and I just want to share with you guys. And that's it.
Okay, a minute. Tuesday was Sonia. Okay, so we've heard a lot of talks from the general down to the specific on some of the operational experiences. One of the things I wanted to just wrap up with is that the 2010 Network World Convergence and VoIP alert for 2010, some of the predictions, one of them was that SIP was going to become more mainstream and that non-traditional carriers would be offering, who were offering inexpensive voice services will find more success. A second one that I found really interesting was that for you to look for businesses to positively influence hosted services opportunities. And there's going to be a shift in how businesses buy hosted services over the next year actually. Business unit owners are going to be choosing to spend their dollars that were originally meant for IT infrastructure on a way to generate revenues. And so with that said, I would like the panelists to comment on these predictions if they would like, and or answer the questions, or what are some of the services that they think are important, and how would you plan on delivering these services to the market in this this year, and what are some of the key services the audiences are looking for. So with that, I'm going to open it up. Let's start with Tim.
So what we're seeing is a couple of things. One is non-traditional wireless or wireline carriers basically will not be able to tap into the SMS world. They see all these wireless guys, Verizon Wireless, AT&T, making a ton of money off of texting. And some wireless operators are saying that at some point in the next couple of years, they're going to make more money off of messaging, whether it's MMS or SMS versus voice. Voice to them is becoming free. Where they're going to make their money off of messaging. So that's one key area we're seeing is wireline operators want to tap into that world. And another is enterprises want to be able to, a lot of enterprises have these great, really full-featured IP PBXs that can do a lot of things beyond voice. However, they generally don't do anything beyond voice outside their enterprise. So if they can do video calls between enterprise A to enterprise B, or instant messaging or share presence information, those kind of things are trends we're seeing that we think are going to happen in 2010 and beyond.
From Sprint's perspective, all the voice side, it really has to do with cost cutting. So the SIP VoIP voice over IP is more cost effective. So that's what we're going. On the sales side, we do see a lot of opportunities to support enterprise IP PBX, and that's also one of the areas we're gearing up to.
Yeah, I think Comcast Business Services team, is looking at the same thing, providing, SIP type trunk to enterprises internal to the network, so maybe less transparent, I think, externally, but just using SIP for intelligent voice call routing, starting to deliver features, AIN equivalent type things, as an operator, that SIP becomes a nice replacement protocol to do that. So at least right now, I see it more as a replacement protocol, I guess, than potentially a new revenue-generating protocol for majority of Comcast. But it's a very nice replacement protocol. And while there are a lot of inter-carrier interop issues, I think as you start working those out internal to your own network, that you become much better versed to approach now external carriers.
Yeah. Pardon me. Yeah, we're seeing a lot of growth into the application, like using SIP for lots of interesting and different things, and voice being just a small piece of it, and the enterprise is all wanting to go for the totally integrated service and experience.
Okay. Any questions from the audience?
Hi. During the past year, we had a number of our clients who wanted to move over to a VoIP-based solution as a call gateway. And they wanted to do it beyond just cost savings measures. They wanted to do it for the versatility and the flexibility that it offered. 100% of these customers rolled back to using PRIs because of the experience. I could tell you that our network has very little jitter, very little latency, but their experience was still horrible nonetheless. Is there a standard for doing voice QoS that could be used inter-carrier so that it would facilitate the use of VoIP and SIP between carriers and be able to make the use of call gateways more effective?
Anybody want to take a?
Yeah, I think on our network, we do have those probes and that can measure the end-to-end voice quality. And actually, that's one of the ways for the voice knock to pinpoint an IP problem. That's the first if they find out there's a latency issue, there's jitter issues, then that's how it comes to them. So for the end user application, probably it comes down to the cost issue, how you really proactively measure this type of yeah.
Well, I guess the question I'm asking goes beyond measuring. It goes to, you guys are a tier 1 provider, and you have a lot of flexibility that the folks that are delivering the consumer grade, the folks that our business clients are connecting to as call gateways, don't have. How can we deliver those services, or how can we deliver better services through these call gateway organizations that deliver these types of services? I don't know if Sprint offers it to small and mid-sized businesses, but there are a number of organizations out there that do offer that, but the experience has not been a good one.
Right. One of the issues with the QoS is it's not really a network element problem, it's an end-to-end problem. And to be honest, I'm not aware of any really standards out there. I mean, one of the things I've seen is obviously making sure your codecs are in sync, but even codec implementations, even if they say they're G.711, the chipset that implemented 711 for this one vendor is a little bit different than the one that did it for the other vendor. So it's a difficult problem, especially for voice, because voice is so sensitive to jitter and everything else. So I guess to answer your question, there's no real good standard. If you can keep it on one network as much as possible, that's good. You can keep as much control over it, but as soon as it starts hitting other networks and other networks, it becomes difficult. I mean, there's things to measure with MOF scores to see what the voice quality is, but there's no really clear standard. It really is an interoperability issue.
Yeah, I agree.
Yeah,
Thank you.
it's all about figuring out what works best for that one instance. I kind of alluded to that in my slides of each vendor has their own implementation, and sure, there are standards, but the way that they implement the standard doesn't necessarily align with the next vendor. And, you know, the proprietary way of doing it, so their special messaging is going to, you know, provide the better quality, but you have to have, you know, that one vendor to do everything. And when you try and convert from one codec to a different codec and, you know, turn on a feature here, turn off a feature there, it just becomes a real mess, and it takes a lot of time and is really quite painful trying to make it work and trying to replicate the quality of the that people have come to expect from the PSTN. But at the same time, people are also learning to expect less from, you know, their mobile phone.
Tom?
Yeah, so Tom Daly from Dining. This is a specific question for Matt. You were using, you know, a lot of SIP-based failover techniques to route around outages in your network when you have an issue. I'm just curious, you know, you're essentially looking for sonic-grade failover. Are new developments like bidirectional forwarding detection offering you anything that gets you to that level, or is it just not there yet? Have you tested it? What does that sound like for you guys?
They could be. I'm probably just not the right guy to answer it. So I'm closer to the application side than I am to the BGC side. But our approach has been, you know, very basic. You know, we're not changing any of really the default configurations. We're not trying to force BGP to do anything that it's not already very good at. And we add in availability and redundancy at the SIP layer as almost an insurance policy, right? You know, we don't expect to have to route advance, you know, to a second carrier very often, but in the event we need to, it's there. So why not take advantage of that intelligence?
How about just in terms of trying to keep the calls that are in progress up?
Well, in that, you know, so the BGP convergence time becomes, you know, that's where it becomes an issue. If we have, you know, a noisy router, you know, something that's tend to provide problems, then we throw in a maintenance window and we'll take that particular router out for a while and make sure that we're addressing the issue. Because you're connecting to a peer at multiple locations and you have multiple transit providers, we can afford to do that, right? That we have that luxury.
Thanks.
You bet.
Anton Capella, 5.9's data. If we're moving towards the direction where we can kind of signal, you know, a number of codecs, we have a choice, you know, 711, 729, and a lot of you mentioned that, you know, some of the troubles, but some of the benefits have certainly been that flexibility. With that in mind, it strikes me that, you know, we could maybe enjoy some AMR wideband or G.722 at some point if this is going to kind of be the way things are tracking. Do any of you guys see that happening from customer interest yet? Or corporate, certainly, you know, multi-site teleconferencing and things like that seem just right alongside this, maybe somewhere.
Yeah, definitely. Cablevision is actually doing high-def voice codecs in their network already. So I think it's easy to do internal to the network, much like we have, you know, challenges on the SIP interop side. You have to have that SIP interop in place first, and then integrate, add HD voice on top of it. So I think it's a very attractive feature, and a positive externality that comes with SIP peering, but you have to have the SIP peering in place first.
Well, and that's exactly what I've been finding is difficulty. We have a number of customers on a hosted Cisco platform in my hometown, and of these 1,000 handsets, they can all speak to each other just fine with HD voice, and everything else works great. But I can't find a SIP trunk person who will even accept that codec in the SDP, so it doesn't get very far.
Yeah.
But it seems like it shouldn't have a reason that it couldn't get very far.
Yeah, Yeah, I agree. I mean, and you negotiate the codec on a per session basis. So as long as both ends can talk HD, then it's fine. But I just don't think there's been enough of a market demand for it yet to drive, really the penetration the way that hopefully we'll see it in the next 5 to 10 years.
Thanks.
Yeah, from the carrier side, the codec, the DSP chip is the most expensive component, so we try to dumb it down as much as possible. Maybe that's why. In the middle of the network, you always see it's G.711.
Thank you.
Okay, one more question?
Karahobia Faikura. Has there been any interest in the U.S. to develop a dedicated SIP exchange point for voice, an exchange point for voice traffic only, or SIP traffic?
Could you repeat the question?
Has there been any interest in the U.S. to develop a dedicated SIP exchange point for just exchanging SIP traffic?
Yes. So it's a couple of folds. We're trying to there are two problems to solve. One is the routing side of it, and one of it is the actual interconnection function. So I know that my company is we work with companies like Equinix, who is here, to try to have them facilitate the actual bearer traffic. And then Neustar was actually working on the routing side of this. So, but to specifically answer your question, nothing on a large scale exists right now. That's kind of was my point about we need a class 4 IP network. Those still need to be out there.
In Finland, many carriers have already changed their voice backbone to IP.
Right.
And it's a dedicated IP network. And they are planning to interconnect these.
Correct. Yeah, the issue in the United States is, it goes back, I think everybody's made the point, inter-carrier compensation. It's not a technical problem, it's a business and regulatory problem. That's really our big stumbling block, I think.
Okay. Well, this concludes our panel. Oh, sorry. Yes. Yeah. This concludes our panel. It's time for the break, and we hope you enjoyed it. Thank you.